Elon Musk's New World Mission, SpaceX and the Colonization of Mars. Introduction to SpaceX and Elon Musk's vision. Elon Musk, the founder of SpaceX, is on a mission to make humanity a multi-planetary species, with Mars as the primary target. This ambitious goal is rooted in Musk's desire to safeguard the future of humanity by expanding our presence beyond Earth. SpaceX, since its inception, has been at the forefront of pioneering space technologies, and its Mars colonization program represents the pinnacle of these efforts. Musk's vision is characterized by a blend of innovation and practicality. He believes that colonizing Mars is not just an endeavor for survival, but a means to drive human progress and innovation. SpaceX's approach to this monumental task involves developing advanced technologies capable of transporting humans and sustaining life on the Red Planet. Central to SpaceX's strategy is the development of the Starship, a fully reusable spacecraft designed for deep space travel. This vehicle is intended to carry large numbers of passengers and cargo, making interplanetary colonization feasible. The Starship's design includes features to support long-duration missions, such as life support systems, spacious living quarters, and the capacity to produce its own fuel on Mars using local resources. In addition to spacecraft development, SpaceX is focusing on the technological innovations required for sustainable living on Mars. The company is working on life support systems that can produce oxygen and manage waste, as well as agricultural technologies tailored for Mars' environment. These innovations are critical for creating a self-sustaining colony. Mars' harsh environment necessitates robust solutions for survival. SpaceX is researching ways to protect colonists from the planet's extreme temperatures and high radiation levels. The development of durable habitats that can withstand these conditions is a key component of the colonization plan. Musk's vision extends beyond the technical aspects of Mars colonization. He sees the endeavor as a way to inspire and mobilize global efforts towards space exploration and technological advancement. By setting audacious goals, SpaceX aims to push the boundaries of what is possible, fostering a culture of innovation that could benefit various sectors on Earth. The journey to Mars is fraught with challenges, but Musk remains optimistic. His pragmatic approach, combined with SpaceX's track record of success, has garnered significant attention and support from both the public and the private sector. As SpaceX continues to break new ground in space exploration, the dream of making life multi-planetary edges closer to reality. The company's progress in reducing costs through reusable rocket technology, coupled with Musk's relentless drive, positions SpaceX as a leader in the quest to colonize Mars. This visionary pursuit, while ambitious, embodies the spirit of exploration and the quest for knowledge that has propelled humanity forward for centuries. Technical aspects of Mars colonization. Transporting humans to Mars involves significant challenges, starting with the journey itself, which can take several months due to the distance between Earth and Mars. Spacecraft designed for this mission need to support life for extended periods. SpaceX's Starship aims to meet this requirement by carrying a large number of passengers and cargo to Mars. Sustainable living on Mars will necessitate groundbreaking technological innovations. The Martian atmosphere is thin and consists mostly of carbon dioxide, rendering it unbreathable for humans. Hence, life support systems that generate oxygen and manage waste are essential. Furthermore, food production must be localized, potentially through advanced hydroponics and agricultural technologies adapted to Mars' unique conditions. Energy production also poses challenges. While solar panels might serve as the primary source, they need to be efficient enough to withstand the planet's dust storms and varying sunlight. SpaceX is also developing systems to utilize local Martian resources for fuel and building materials. The ability to produce fuel on Mars would significantly reduce the need for supply missions from Earth, making the colony more self-sufficient. Similarly, using Martian soil and other local materials for construction could lower costs and simplify logistics. Habitat design is another critical area of focus. Mars' surface experiences extreme temperatures, and the lack of a protective atmosphere increases radiation exposure. Developing durable, insulated habitats that can shield inhabitants from these conditions is paramount. These habitats must also offer a comfortable living environment to support the physical and mental well-being of the colonists. The spacecraft and habitats will require robust systems to handle the unique challenges of Mars. This includes reliable life support, waste management, and radiation shielding. Technologies for recycling water and air will be crucial to maintaining a sustainable living environment. SpaceX is also looking into how to best provide adequate medical care for the colonists, addressing both routine healthcare needs and potential emergencies. Communication between Mars and Earth presents another technological challenge. The time delay, which can be up to 24 minutes one way, complicates real-time communication and requires advanced systems for autonomy and problem-solving on Mars. This necessitates the development of sophisticated artificial intelligence and automated systems to assist in daily operations and emergency situations. Establishing a human presence on Mars involves overcoming numerous technical obstacles. SpaceX's approach integrates advanced engineering, innovative life support systems, and sustainable resource utilization. As these technologies develop, they will not only pave the way for Mars colonization, but also contribute to advancements in space exploration and related fields. Environmental and biological challenges. Mars presents a harsh climate that poses significant risks to human survival. The planet's surface experiences extreme temperature variations, with highs barely reaching above freezing and lows plunging to well below -100 degrees Fahrenheit. These fluctuations necessitate advanced thermal regulation systems in habitats to maintain a stable and livable environment. The absence of a protective atmosphere further exacerbates the challenge, as it allows for increased exposure to cosmic and solar radiation. Effective shielding is required to protect colonists from these harmful rays, which could lead to severe health issues over prolonged exposure. The Martian soil, known as regolith, is not inherently suitable for agriculture due to its lack of essential nutrients and presence of toxic chemicals, such as perchlorates. Innovative agricultural techniques, possibly involving hydroponics or soil conditioning, will be crucial to grow food locally. This not only provides sustenance, but also reduces the dependency on supply missions from Earth. Another significant challenge is Mars' low gravity, approximately 38% of Earth's. The long-term effects of reduced gravity on human physiology are not yet fully understood, but potential issues could include muscle atrophy, bone density loss, and cardiovascular problems. Countermeasures such as specialized exercise regimens and possibly even pharmacological solutions will be necessary to mitigate these effects. Isolation and confinement in a remote environment like Mars can have profound psychological impacts. The vast distance from Earth means that colonists will be far removed from family, friends, and familiar surroundings, leading to feelings of loneliness and homesickness. The limited social interactions and confined living spaces could contribute to stress, anxiety, and other mental health challenges. Establishing strong support systems, including mental health resources and recreational activities, will be essential to maintain the well-being of the colonists. The lack of a breathable atmosphere means that colonists will rely entirely on life support systems to provide oxygen and remove carbon dioxide. Any failure in these systems could be catastrophic, making their reliability and redundancy critical. Water is another precious resource that will need to be carefully managed and recycled, given the limited availability on Mars. Healthcare on Mars will also face unique challenges. The remote location complicates medical emergencies, requiring advanced telemedicine capabilities and possibly even robotic surgery. Preventative health measures will be crucial to minimize the risk of illness and injury in such an unforgiving environment. Economic and ethical considerations. SpaceX has outlined ambitious timelines for Mars exploration, with initial missions aimed at testing systems and technologies necessary for future human missions. The first crewed mission to Mars is tentatively planned for the late 2020s, contingent on the success of preliminary unmanned missions and further advancements in technology. The potential impact of a successful Mars colonization effort is enormous. It could redefine human civilization, sparking new economic opportunities and cultural shifts. Moreover, it would mark a new chapter in space exploration, serving as a catalyst for further ventures beyond our solar system. While many challenges lie ahead, the prospect of human settlement on Mars remains an exciting and transformative goal for our species. Future prospects and timeline. SpaceX envisions a future where Mars is a thriving colony, contributing to human advancement in myriad ways. The timeline for this ambitious project is aggressive yet grounded in technological milestones and incremental progress. The first crewed mission to Mars is tentatively planned for the late 2020s, contingent on the success of preliminary unmanned missions and further advancements in technology. One of the key steps in this timeline involves a series of unmanned missions to Mars to test critical technologies and gather essential data. These initial missions will focus on landing, surface operations, and resource utilization. By deploying advanced robotics and automated systems, SpaceX aims to prepare the Martian surface for human arrival. These missions will also test the efficacy of in-situ resource utilization, ISRU, including the production of oxygen and fuel from local materials. Following successful unmanned missions, SpaceX plans to launch cargo missions to transport the necessary infrastructure for human colonization. These missions will deliver habitats, life support systems, and other essential equipment. The deployment of these assets will create a preliminary base that can support human life. This base will be crucial for providing shelter, food, and medical care for the first wave of colonists. As these foundational steps are completed, SpaceX will turn its attention to crewed missions. The first human explorers on Mars will have the monumental task of setting up the initial colony, establishing life support systems, and starting the first experiments in Martian agriculture. These early colonists will be pioneers, facing unprecedented challenges and paving the way for future settlers. Their experiences will provide invaluable data for improving and scaling up the colony. The timeline for Mars colonization extends beyond just the initial landings and setup. Over the next few decades, SpaceX aims to expand the Martian colony into a self-sustaining settlement. This involves increasing the number of inhabitants, building more advanced infrastructure, and developing local industries. The goal is to create a colony that can thrive independently of Earth, with its own economy and social systems. Economic opportunities are expected to arise as the colony grows. Industries such as mining, manufacturing, and tourism could become viable on Mars. The unique environment may also spur innovations in fields like biotechnology, renewable energy, and materials science. These advancements could have far-reaching implications, benefiting not only the Martian colony, but also humanity as a whole. Ethically, the colonization of Mars raises important questions. Issues such as planetary protection, the rights of future colonists, and the environmental impact of human activities on Mars must be carefully considered. SpaceX is committed to addressing these concerns, ensuring that the colonization process is conducted responsibly and sustainably. This includes adhering to international guidelines for space exploration and collaborating with scientific and regulatory bodies. Culturally, the establishment of a human presence on Mars could lead to significant shifts in our collective consciousness. It may foster a sense of global unity as people from different nations come together to achieve a common goal. The challenges and triumphs of Mars colonization could inspire future generations to pursue careers in science, technology, engineering, and mathematics, STEM, driving further advancements in these fields. The long-term prospects for Mars colonization include the potential for terraforming, a process that could make the Martian environment more Earth-like. While this is a distant goal, requiring centuries of effort and technological breakthroughs, it represents the ultimate vision of making Mars a second home for humanity. Terraforming would involve altering the planet's atmosphere, temperature, and surface conditions to support liquid water and a stable ecosystem.